So our topic is canonical correlation. Canonical correlation analysis is the study of linear relation between two sets of variables. It is the multivariate extension of correlation analysis. So for example, suppose you have given a group of students two tests of 10 questions each and wish to determine the overall correlation between these two sets. Canonical correlation finds a weighted average of the questions from the first test and correlates this with the weighted average of the questions from the second test. The weights are constructed to maximize correlation between these two averages. This correlation is called first canonical correlation coefficient. Now you can relate another set of weighted averages unrelated to the first and calculate their correlation. This correlation is the second canonical correlation coefficient. This process continues until the number of canonical correlations equals the number of variables in the smallest group. Now there are three special cases of canonical correlation. These are the discriminant analysis, MANOVA, and multiple regression. It provides the most general multivariate framework. Because of this generality, it is probably the least used of the multivariate procedures. Researchers would rather use the specific procedures designed for their data. However, there are instances when canonical correlations techniques are useful. So let's have more examples of canonical correlation analysis. For example, a researcher has collected data on 3 psychological variables, 4 academic variables standardized test scores, and gender for 600 college freshmen. She is interested in how the set of psychological variables relate to the academic variables and gender. In particular, the researcher is interested in how many dimensions are necessary to understand the association between the two sets of variables. If you can recall that canonical correlation analysis is the association between two sets of variables. So if we're going to relate that on our example in the SPSS, which by the way we use the example given on our midterm, the questionnaires from Lyceum. To apply it, we're going to analyze, correlate, and go to canonical correlation and choose two variables. In this, we chose position, age for variable 1 and facilities, personal hygiene, safety, and health for the variable 2. To get the result, press OK and that's it. These are the results of our canonical correlations. So to better analyze the result we got a while ago, I researched from another example on the internet and the results of its procedure. The first portion of the result of canonical test will contain some multivariate test for statistical significance. The second result will show the actual listings of canonical correlations. And the first canonical relation is always the largest because it was selected to maximize the associated association between two sets of variables. The third table that the result will show you is an F-test for individual dependent variable. The fourth will show you standardized canonical loadings for each dependent variables and so on. So what are the practical use of canonical correlation? A typical use of canonical correlation in experimental context is to take two sets of variables and see what is common amongst two sets. Also, one can also use canonical correlation analysis to produce a model equation which relates to two sets of variables. For example, a set of performance measure and a set of explanatory variables, or a set of outputs and a set of inputs. Constraint restriction can be imposed on such model to ensure it reflects theoretical requirements or intuitively obvious conditions. This type of model is known maximum correlation model. Canonical analysis in simple definition is a multivariate technique which is concerned with determining the relationships between groups of variables in a dataset. The dataset is split into two groups, X and Y, based on some common characteristics. The purpose of canonical analysis is then to find the relationship between X and Y, that is, can some form of X represent Y. It works by finding the linear combination of X variables, that is, X sub 1 and X sub 2, etc., and linear combination of Y variables, that is, Y sub 1 and Y sub 2, etc., which are mostly highly correlated. A canonical variate is a new variable or variate formed by making a linear combination of two or more variates or variables from a dataset. A linear combination of variables is the same as the weighted sum of variables, because we can infinitely many ways choose combination of weights between variables in a dataset. There are also infinitely many canonical variates possible. So in general, additional constraints must be satisfied by the weights to get a meaningful canonical variate. For example, in canonical correlation analysis, a data set is split up into two parts, a dependent and an independent part. In both parts, we can form canonical variation, and we choose weights that maximize the correlation between these canonical variates. And these are the algorithm that calculates these weights. Now, what is the comparison of canonical variate analysis and principal component analysis? Principal component analysis is most often used to generate a product map from sensory profiling data. It does not take into account variance of products mean scores due to individual variability. While canonical variate analysis is the two-way product and subject multivariate ANOVA model, is the natural extension of classical univariate approach, consisting of ANOVA of every attribute. So just imagine if there is no SPSS, then this would be the computation we have to go through to get the canonical variation. So that would be all for our topic, canonical correlation. Thank you for listening.